Hello, everybody. Thank you for joining us. Today, we'll be talking about scaling business messaging at WhatsApp. WhatsApp is a messaging app that's used by over 2 billion people in 180 countries. WhatsApp is end-to-end encrypted, which means that all your messages are private. WhatsApp is also used by a lot of businesses across the world. They use it to run their operations and talk to their consumers. Let's look at how businesses use WhatsApp. There are primary two modes of using WhatsApp. On one end of the spectrum, we have Jasper's Bakery, a fictitious local bakery. Jasper's Bakery has 5 employees and they service hundreds of consumers in their area. They use WhatsApp to talk to their vendors, run their operations, and stay in touch with their consumers. They love the simplicity of the WhatsApp business app. The WhatsApp business app is very much like the regular WhatsApp app, along with a lot of useful business tools built in. For instance, they get access to a catalog. They get access to greeting messages. They get access to lists. And they also get access to an AI bot, besides a lot of other features. Being a small business, they also appreciate the fact that WhatsApp Business App is available for free. They are aware that operating out of mobile apps will limit scale eventually, but that's not a problem for them at the moment. On the other side of the spectrum, we have AirlineGo, a fictitious international airline. With thousands of global employees and millions of users, it's not practical for them to use mobile apps. So they use Cloud API, which is provided by Meta, which is a programmatic interface to sending and receiving messages. They've built and deployed a lot of interesting tools on top of Cloud API, including the ability to send boarding passes and running a helpline for all their consumers. They don't mind paying for access to Cloud API because of the global penetration that they get. And they love the fact that they can scale seamlessly. Let's go back to Jasper's Bakery for a little bit. Jasper's Bakery has been doing very well. They now have a lot of bakeries across the city. They now hire dozens of employees and service thousands of consumers. So they're looking to get more from WhatsApp. For instance, they want to do things like run a large marketing campaign across the city. They want to send automated birthday wishes to all their consumers. And they've always been wanting to automate their status update system. A lot of these features are not available on the WhatsApp Business app, so now they need access to Cloud API. Unfortunately, Cloud API features are not available in an a la carte mode. The only way for them to get access to Cloud API is to migrate to Cloud API. Now, migration to Cloud API is a big deal for a small business like Jasper's Bakery. There is a high cost of switching because they're moving away from a simple mobile-based interface to a programmatic interface. This also needs a lot of technical expertise in-house, either something that they develop in-house or start engaging third-party vendors. So this puts Jasper's Bakery in a position where accessing scale is very difficult. Ideally, we'd want to provide access to both to Jasper's Bakery. We would want to let them stay on top of the WhatsApp Business app and pair Cloud API. Now, this sounds like an obvious solution, and it is, but it's a non-trivial problem to solve. In this presentation, we learn about the technical complexities of pairing Cloud API. Then, we'll talk about how we leverage the multi-device protocol to solve this problem. And finally, we'll talk about some interesting upcoming problems. So, let's start by digging deeper into what we mean by pairing Cloud API. Let's start by understanding what we mean by pairing. So, let's go back a step and let's start with a non-end-to-end encrypted messaging system. So in this scenario, we have Alice on the left with 2 devices and Bob on the right with 1 device. So Alice wants to use both these devices, so they register these devices with the server. Now when Bob wants to send a message, Bob sends the message to the server and the server sends the message to both these devices. Now there's a problem here. Let's look at a hypothetical malicious scenario where the server injects a device D3 into the mix without Alice or Bob knowing. So when Bob now sends the message M to the server, this message is also going to be delivered to D3. Obviously, this is an oversimplification, but the point is, in such a system, the server needs to be trusted. Now, let's look at WhatsApp, an end-to-end encrypted messaging solution where things are different. So let's start by saying Alice has 2 devices and they register these 2 devices with WhatsApp. Again, there is a malicious device in the mix. Now, when Bob wants to send messages, instead of sending the message to the server, Bob gets all the devices that belongs to Alice from the server. So now Bob has the ability to authenticate all these devices using a QR code. This is when Bob and Alice are able to meet up in person out of band and scan each other's QR codes to run pairwise authentication and authenticate each other's devices. This puts us in a position where a malicious actor cannot lie to either Bob or Alice about the set of devices that they own. So coming back, the QR code verification would have failed for D3 because it's not a legitimate device, and Bob ends up sending messages only to D1 and D2. So this pairwise device authentication is actually a very critical part of end-to-end encryption. But unfortunately, it doesn't scale. As users acquire more and more devices, the cost of pairwise authentication increases exponentially. Now imagine the same setting in a group setting where we have a lot of users, each user with a lot of devices, and at this point, it's practically impossible to run pairwise device authentication. So the solution here is what we call pairing or the multi-device protocol, where we start by extending authenticity between the user's first devices, which we call the primary device. And subsequently, as they acquire more devices, we extend the authenticity that has already been established. Now that we understand what pairing means and what we really have to do on the pairing side, let's talk a little bit about Cloud API. Let's start by understanding what Cloud API really is. Cloud API, like we mentioned in the past, is a programmatic API that is built by Meta and hosted on Meta servers. It gives you programmatic access for various operations, including sending and receiving messages. You get access to webhooks, which gives you a lot of events when certain operations happen. Anybody can sign up for a Cloud API account using their phone number, just like a regular account. The big difference is the fact that Cloud API resides on the server as against your mobile device, which always resides with you. And the very fact that the Cloud API resides on the server brings in a lot of additional complexities. There are a lot of complexities, but let's start by looking at two of the important complexities. The first one is scale. So we're talking about the situation where we are taking the WhatsApp business app and pairing it to the Cloud API. Now, Cloud API is going to give you access to immense scale, being able to send hundreds, if not thousands of messages every second. The WhatsApp business app, being a mobile app, is not going to be able to handle this kind of scale. So we need some additional handling to make sure that the ecosystem continues to remain useful to businesses. This is a very deep problem. However, we are not going to be talking about this problem in this presentation. What we are going to focus on instead is the end-to-end encrypted state of Cloud API. Cloud API, like we mentioned, is a server endpoint. And even though it uses the same encryption protocol, is declared non-end-to-end encrypted. This is again because of the fact that Cloud API resides on a server as against your personal device that always resides with you. So this again has some implications because WhatsApp is an end-to-end encrypted environment. So we have three requirements here. To start with, we want all our users to be able to cryptographically detect that they're talking to Cloud API. Point number two is after they're able to detect that they're talking to Cloud API, we need a mechanism to show guaranteed disclosures to all our users. This gives our users the ability to choose if they want to continue the conversation or stop the conversation. The third thing that we want to do is be able to put in additional restrictions. Bringing in Cloud API brings in a lot of complexities, as we will see. So we want to limit the conversations that Cloud API is able to participate in only to one-on-one chats. So now that we understand what pairing Cloud API really means, let's understand how we are able to leverage the multi-device protocol to pair Cloud API to the WhatsApp business app. A quick disclaimer, all the code and diagrams that you're going to see in the following slides are for illustrative purposes only. The exact technical details are available on the WhatsApp white paper, which is published on the internet. So let's go back to Jasper's Bakery and let's walk through Jasper's Bakery's journey. So let's start from day zero, where Jasper's Bakery is a single employee. We have Alice on the left and Bob on the right as their consumer. They both use WhatsApp and they have a single device each. They start day one by authenticating their devices using the out-of-band QR code. Now, Jasper's Bakery has a new employee, so Alice wants to add a new device to their account. Let's see what this looks like under the hood. We have the primary, which is the first device that Alice owns. We have the WhatsApp server. And on the right, we have the companion device, which is the new device that Alice is trying to pair. So the companion device starts by creating a QR code and embedding an identity and some metadata into it. This identity is a cryptographic public-private key pair, where the companion device embeds the public part into the QR code, You can really think of your identity as your email address, which has a public part, which is the actual email address, and your private part that is private to you. So this acts as your identity on the open internet, and it also lets people send you messages. But you are the only one who's going to be able to read these messages because you are the only one with access to the private component. So coming back, we have the identity key embedded into the QR code. The primary device now scans this QR code. This is when the primary device is introduced to the companion device for the first time via its identity. Now, the primary takes the identity of the companion and signs it with its own key. You can think of this as a literal signature and as a contract that's being established between the primary device and the companion device. So the contract has been written up and it's passed to the primary, and the primary signs it from their side. So the primary also maintains a list of devices it owns. So the primary takes this information and adds it to its own list. Alongside this, the primary also signs this list to indicate that the add operation that was performed was a legitimate operation. The primary then takes all this information and sends it to the server. Now the server takes the signature and the information about the device back to the companion. Now think of going back to the contract analogy. Think of this as a contract being completed. Now the companion has access to this information, which it signs with its own identity key, and it sends it back to the server. At this point on the server, we have two pieces of information. We have a list of devices along with a signature on it indicating that it's an authentic list, and we have information about each of these devices, which is co-signed by both the primary and the companion. This puts this whole information in a situation where a malicious actor cannot change it without people in the ecosystem noticing a change. So now, let's come back to Jasper's Bakery. Now, Alice has two devices, and Bob now wants to send a message to Alice. Let's see what this looks like under the hood. So let's fill in this code send message where Bob is trying to send a message to Alice, and the message that they're trying to send is text. So the first thing that Bob needs to do is pull down the list of devices for Alice and validate the list signature. So Bob is able to do that using Alice's primary key and the list signature. The next thing that Bob does is iterate through all the devices and validate the signature of each other device by cross-validating it with the signature for the primary and the signature of the companion device. At this point, all the devices are deemed legitimate, and for each other device, Bob encrypts their message and sends it out. So Bob sends a message to Alice. Now Alice responds with a message. Now let's look at what Bob's receiving side code looks like. So we want to fill in this function where we got a message from a device D, which is claiming to belong to Alice, and the actual ciphertext that we received is C. So the first thing that Bob needs to do is to figure out if it is the primary device. If it is the primary device, it's already being authenticated via the QR code authentication that happened at the very beginning. If it is one of the newer devices, Bob needs to validate it using the multi-device protocol, where they compute the signatures of the device from the primary side and the companion side, and then they validate it. At this point, this device is deemed to be a valid device and indeed belong to Alice, so it's decrypted and rendered on the screen. Now things get interesting. So Alice just opened their 10th bakery, and they now want to pair Cloud API. So let's see how we have to change the multi-device protocol to accommodate this to hit all our goals. So we are back in a relatively similar setup where we have the primary device, we have the WhatsApp server, and now we have Cloud API. So Cloud API generates a QR code again with the same information. The primary scans the QR code and extracts the identity. And here, the primary does something different. They throw in a special prefix that's earmarked for Cloud API into the signature, and they also record the fact that they're talking to Cloud API along with the signature on the same piece of information. Apologies for the shorthand there. So now, let's see how this seemingly small change is able to help us hit all our goals. So goal number 1 was detection. Ensure that when Bob is talking to Cloud API, Bob is able to cryptographically validate that they're either talking to Cloud API or not talking to Cloud API. So let's go back to the receive message code. Now that we have this Cloud API bit, we can use it, and by validating the signatures, we can say that we've been able to cryptographically assert if you're talking to Cloud API. But there is one problem here. Imagine that Cloud API sends the message to a client which is old and thereby does not have the capability to run this cryptographic signature validation. because we changed the signatures the way the device was originally signed, this means that the actual signature validation is going to fail. This puts the device in a state where it's actually not going to decrypt and render the message. So because of this change, we've been able to get into a position where all new devices that are able to validate signatures and are able to assert that we're talking to Cloud API are going to decrypt and render the message. Any device that is not capable of asserting the signatures and detect that they're talking to Cloud API are not going to be rendering this message. Let's look at our second goal, which was to make sure that we always show disclosure when a user is talking to Cloud API. Let's go back to the receive message on Bob's side. Now that we have this field which determines if you're talking to Cloud API or not, we can use that information to show disclosures if necessary. Now, there is always a chance that showing a disclosure fails, which puts us in a position where we've not shown the disclosure but have still rendered the message, which sets an incorrect expectation for the user. Now, this might sound pedantic, but at WhatsApp scale, it's very important for us to look into every possible corner case. A simple solution to this whole method is wrapping the whole process in a transaction. This puts us in a position where if you're not able to render a disclosure, we don't even render the message. This gives us guaranteed disclosures. The third goal that we had was to make sure that we restrict communication with Cloud API only to one-on-one messages. So let's look at Bob's sender side code. Again, given that we have access to the Cloud API field and we have a mechanism to validate that it's authentic, this becomes trivial, where we can just check if you're talking to Cloud API, and then we only send messages to Cloud API if you're in a one-on-one conversation. For all other conversations when Cloud API is paired, we just do not send a message to Cloud API. So what did we achieve? We set out with the goal of pairing Cloud API to the WhatsApp Business app. This gave businesses like Jasper's Bakery a la carte access to features from Cloud API while retaining the simplicity of the WhatsApp Business app. We ran into a lot of security hurdles, which we crossed by adapting the multi-device protocol to enable pairing Cloud API in a safe manner. With this, we've effectively been able to open up scaling to businesses like Jasper's Bakery. What's coming up next? So we briefly touched upon the problem of scale. Scale is a very deep problem and it will need a multifaceted solution. This is obviously one of the next big problems that we need to solve. We also need to be very careful about opening up Cloud API access to different modalities of communication. As we've seen, bringing in Cloud API into different modalities brings about a lot of complexities. So it's very important that we pick and choose features to maximize value for businesses and consumers. Finally, we want to ensure that we are always upholding our privacy promise to all our users. So this always is a number one priority for us. If you found this interesting and you want to work on problems like this, please check out our career portal. And thank you for taking the time to join us today.